Awesome, thank you. Looking good. So yes, we only have 8 days left of trimester 2, and then courses are over. So just so you know, as a heads up, next week we will have a very, very short unit, Unit 5, where we talk about acids and bases, and then you'll have your final exam, and that's it. We will be done for the trimester, and then the following week is the week where we actually end. You'll have a couple catch-up days just to catch up on any work that's missing. The Unit 4 project was loaded on Wednesday for you, along with recordings that go over the first 6 slides on Wednesday. Wednesday went over slides 1 through 6, and Thursday went over slides 7 through 9. Today we're going to go over slides 10 through 12. Okay? Now, keep in mind, I know that when you first open the project, it looks like there's a lot of slides, but remember there is a blue option, a purple option, a yellow, and a pink option. You only have to choose one of the 4 options, so feel free to delete all the other slides. You should only end up with 12 slides in total in your project, of which only 5 of them have like real work that you need to do on them. So it's literally a 5-slide long project overall. Everything else is just kind of reference slides. All right, so it's a really easy project. Well, not necessarily, like I know the 3-step stoichiometry problem is a little bit harder, but in general, it's a really fast project. So make sure you watch the recordings from Wednesday, Thursday, and then today we're going to go over slides 10 through 12. And then the recording for slides 10 through 12 will be uploaded this afternoon, which is what we're doing right now. I'm recording it right now. All right, so let's go ahead and take a look here. At this point, if you haven't already, please go ahead and open up your project. All right, so if you have not yet started it, please go ahead and go to your grades tab. I'm going to send the link to the grades tab in the chat box. So here is Mrs. Larkin's grades tab, and here is Mrs. Sepulveda's grades tab. Everything you need is in the grades tab. The templates are in the grades tab. The recordings are in the grades tab. The submission folder is in the grades tab. It's also in the announcements. It's also in the assignment folder description. It's also in the content. It's also in the plan. It's literally everywhere. You have no excuses. If you look at our courses at all, you should be able to find these things. So there are no excuses. Okay, so that being said, scroll down to the Unit 4 project, the reaction project. You'll see like a spinning reaction. It's called the clockwork reaction. It's really cool. There's a Google Slides version that you can make a copy of, or a PowerPoint version that you can download. If you already started it on Wednesday or Thursday, this is the link to the Google Slides folder where you can open up projects you've already started. Or obviously, if you did it on your PowerPoint, then get it from your PowerPoint on your computer. And then I'm going to go ahead and, lower these current hands. Go ahead and again, raise your hand. Once you have opened up your project, you have 40 seconds to do that for me. Again, I do need raised hands from 100% of you. We are going to be very strict. If you are not participating, you will not get attendance for today. So please, please, please make sure you are raising your hand, because today is a day that we need to get through stuff quickly. 25 seconds, raise your hands. I see Derek in the chat. 20 seconds, waiting on Eric, Aria, Monty, Gabriel in the chat, Monique, Timothy, Ame, Kale, Tayan, Jaden, Adriana. 10 seconds. You can also take pictures. Highly recommend you take pictures today, because we're going to kind of go through it pretty fast. Again, that recording will be uploaded around 1 to 2 p.m. But I know it's really helpful to have a picture of it just so that you can start filling out yours, because we're going to go over a lot of like what gets filled in. I'm going to give you lots of the answers. All right, I see Gabriel in the chat waiting on Monty, Monique, Timothy, Ame, Tayan, Jaden, Adriana. All right, Monique, Timothy, let's see here, Tayan, Jaden, Adriana. Okay, I got Timothy. Awesome, thank you. Sorry, so we're still waiting on Monique and Tayan, Jaden, and Adriana. All right, looking good, and we will be checking in with those people. Awesome. All right, yeah, definitely take pictures today. Okay, so this is just a reminder, projects are graded on a 50 through 100% scale, which means as long as you provide a valid attempt on each slide, meaning it's very clear that you filled out the slide while watching the recording, then the lowest grade you can get on that slide is a 50%. Now, if you're filling in anything with gibberish or nonsense, or like I gave you the answers in the recording for what goes in a blank and you didn't put that in, even though I gave you the answers in the recording, then you can still get a 0 on that slide for not giving us a valid attempt. So it's to your advantage to try, it's to your advantage to use the recordings. Again, recordings are in the grades tab, in the announcements, in the class plan, it's everywhere. No excuses. All right, so I'm going to go ahead and show you how to submit it. Again, it is technically due today at 4 p.m., but again, we're not going to look at it until next week, so don't even worry. You have a grace period. We don't grade over the weekend, so don't even worry. We're not going to be like, oh no, so-and-so didn't submit it over by 4 p.m. We don't care. We'll look at it next week, okay? So you have plenty of time. Especially if you didn't get a chance to start it Wednesday, Thursday. So I'm going to go ahead and at least show it to you, though, how to submit it. So let me go ahead and share this with you. All right, so taking a look here, again, if we're in our grades tab, I'm going to go ahead and view this as a student. All right, so if we're in our grades tab, you can scroll down. Here's Unit 1, Unit 2, Unit 3, and our last project, Unit number 4. Again, slides 1 through 6 instructions were uploaded on Wednesday, slides 7 through 9 on Thursday, and today we're going over slides 10 through 12. That recording will be updated between 1 to 2 p.m. Right now it's just a blank recording. You can also see the templates down here, so everyone should have their templates open by now. Here's the submission folder. All right, so you'll click on that. And when you scroll down, you'll be able to see where it says to add a file. Now, if you're doing the Google version, which looks like this, you do need to download it as a PowerPoint or a PDF first, because it needs to be on your actual computer. So you would go to File, Download, download it as a PowerPoint or as a PDF. All right, so I'll download it as a PowerPoint here. Again, these instructions will be in this afternoon's recording, so I'm not going to, don't panic about it, right? So there's that downloaded document. So now I can go to here and click add a file. We want to grab it from our computer and upload it. Again, I already mentioned, Anthony, you will delete any option you don't use. So your project is actually only 12 slides long, of which there are only 7 slides that you actually have to do work on. Again, you delete any color that you're not using. It is not a 40 slide project. All right, so I'm going to go to my downloads folder and grab it. And then once it's uploaded, I'll click add and submit. Again, you guys should already know how to do this. You've already done this for units 1, 2, and 3. Okay? Yeah, perfect. All right, so I do want to show you what the project looks like. Again, keep the first 3 slides. That's your title slide, where you choose your reaction. There are 4 options: the cesium and water explosion, the nitrogen triiodide explosion, the elephant toothpaste explosion, or the gummy bear explosion. All right, lots of explosions. All right, and then slide number 3 tells you which slides to keep. Again, only keep the slides for the reaction that you chose. So if you choose cesium and water, only keep slides 4 through 12, delete the rest of them. That means only keep the blue slides. Nitrogen triiodide, you only need the purple slides. Hydrogen peroxide elephant toothpaste, you only need the yellow slides. And potassium chlorate, which is the gummy bear, you only need the pink slides. Delete all of the other slides for the different reactions. Again, you only need one color. One color. If you try to do all of them, you won't get extra credit. We're only going to grade the first one that we see. Okay? So again, do not do 40 slides. Please only do 12. Right? So I'm going to show you how to delete slides. Again, to delete slides, you can click on the first slide of a section. So if I want to get rid of purple slides, I would click the first slide here of the purple, scroll down to the last slide, and while holding shift, click that last slide. Okay, and you'll see that that highlights all of them. And then you can just right click and delete. Okay, so I'll put those instructions in the chat. Again, click the first slide, hold shift and click the last slide, and then right click and delete. You can delete them all like one by one if you want to, but that's a lot. Okay. So again, you should only end up with with 12 slides in total. If you have more, that means you didn't delete the things you were supposed to delete. If you have less, that means you deleted too much stuff. Okay. So taking a look here, in the instructions, I showed you how to do this. So you observe the reaction, and then you talk about in complete sentences some observations you made. Again, that's slide 4 of the blue, slide 4 of the purple, of the yellow, and of the pink. Then slide 5 gives you the unbalanced equation and a video that shows you how to balance the equation. So watch the recordings. So this video down here goes through how do we balance the equation. I go through pretty much all the steps. You just have to finish it. Like literally most of the answer is there. You just have to finish it. All right, so watch that recording to finish balancing your equation. You have to actually write this one. So this has to be hand drawn with your name handwritten on it, and then you'll insert the picture on slide number 6. Okay, this is extremely important. If your balanced equation is wrong, then every single one of your stoichiometry problems will also be wrong, and your stoichiometry problems are half of your grade here. So you absolutely have to make sure that your equation is balanced, absolutely have to make sure that you inserted the photo of your balanced equation. Again, I already did most of it for you in the help videos, so just watch the help video. All right, that's all I'm asking. So that's what we talked about on Wednesday, was how to do slides 4, 5, and 6. And then yesterday, I uploaded a recording that went over slides 7, 8, and 9. All right. So slide number 7, again, is how to calculate molar masses. I showed every single section. So I showed the pink option, I showed the yellow option, the purple option, and the blue option. I also gave a lot of the answers for each of these blanks. So I showed you, where do you find cesium on the periodic table? How many cesiums are there? What's that molar mass? What does that equal? And then add it all up to find the total. I did the same thing with the other chemical. So again, I already gave you most of the answer. You just have to finish it. So watch the recordings. I cannot emphasize that more. All right. Slide number 8 is just a reference. Again, of the actual slides you have to fill out, there aren't many, right? There's like 12 slides, and of them, there's only really 6 slides that you have to do work on, okay? Slide number 9, I also showed you yesterday, was the one-step stoichiometry problem, the easiest type of stoich problem. We go from moles of one chemical to moles of the other chemical. Again, you have to have your balanced equation. It must be correct. If your balanced equation is wrong, I can guarantee you that your stoichiometry problem will also be wrong. So please make sure that your balanced equation is correct first. All right. So we went from moles to moles. Again, that was all shown to you yesterday. And look at this. Your entire kind of like setup is already filled out for you. I already have your units filled out for you and what gets canceled out. And I already have it showing where you're multiplying, where your final fraction is, and how to get your final answer. Okay, so that is all of those slides. Again, today we're going to go over slides 10, 11, and 12 together. But again, everything for slides 1 through 9 was already provided for you. Green checks, orange X's if you understand how to find that stuff. How to find that stuff. Awesome. Again, do not do every color. Only do one of the 4 colors. Delete the others. I will cry, and you will cry, if you do more than one, right? So you should only have a 12-slide project, of which only half of them have real work on them. It's a short project, I promise. All right, Mrs. Sepulveda is sending out the attendance one last time, and then she will be deleting it from the chat, so make sure you get that done. I'm still waiting on green checks from Michael, Eric. I need your participation. Patrick, Timothy. And let's see here. Jaden, DJ. Green check if you understand. Green check if you understand. Awesome. Again, I'm waiting for green checks from, let's see here. Eric, are you there? Hello. Jaden, DJ. Timothy, if you have a question, make sure you are private chatting Mrs. Sepulveda so she can help you out. Yeah, Gabriel, I see you. You're good. I'm not asking for raised hands, guys. I'm asking for green checks. Please make sure that you're listening to instructions. All right, so we just have not yet heard from Jaden or DJ. Jaden or DJ. I'm not asking for raised hands. I'm only asking for green checks. All right, thank you. Let's go ahead and keep on moving here. All right, there we go. Perfect. All right, I'm going to go ahead and keep on moving here. So we are going to go ahead and talk about the last two problems. So the two-step problem and the three-step problem. I'm going to kind of go through them pretty rapidly, but don't panic. Again, the recording will be uploaded this afternoon, so that way you can pause and go through it step by step at your own pace. So we're going to take a look, and all of these two-step problems look very similar. So whatever we do for the first one is pretty much the same steps we're going to do for all of the other ones too. Okay, so taking a look here. For these, you need to have both the balanced equation and the molar mass of one of your chemicals. The balanced equation again came from slide number 6, your drawing, and the molar mass again comes from slide number 7, where you calculated molar masses of 2 of your chemicals in your reaction. Okay, so again, that's true for the purple version, slide 6, slide 7. That's true for the yellow version, assuming you deleted the slide you were supposed to, and slides pink and the pink slides. Okay, so then taking a look here, let's take a look at this example. How many grams of cesium hydroxide are also formed when 3 moles of hydrogen are produced? Please point for me on the board. What am I given? Do I know the grams or do I know the moles? Point for me up on the board. Which of those do I have a number with? Which of those do I have a number for? Thank you. I see 3 arrows, 4 arrows. I need more participation up on the board. 5 arrows. Purple, what are you doing? You should either be pointing at grams or moles. Yes, perfect. So this is what we're going to start with. We're going to start off with moles. And what am I solving for? Point for me on the board. What am I solving for? What is the thing I don't have a number for? Yeah, exactly. I'm solving for grams of cesium hydroxide. So that's my question mark. So here, again, I'm starting with moles of one chemical right here. And I'm going to grams or mass of another chemical. The middle step, point for me on the board, what would be the middle step? Before I can get to grams over here, what would be my middle step? Point for me up on the board. Thank you. I see 2 people up there. Middle step, middle step. There we go. Perfect. The middle step, not the first step. Yeah, so this would be the middle step. So before I can get to mass of my new chemical, I first have to go to moles of the new chemical. So it's going to be moles to mass. Now this is the exact same setup for the purple version as well. All right, so grams and moles. Moles is what we start with. Grams is what we're ending with. Same thing with our yellow version. Moles is what we start with, in this case of water. And grams of oxygen is what we're ending with, moles to grams. And then right here, moles of potassium chloride is what I'm starting with. And grams of oxygen is what I'm ending with. Okay, green checks, orange X's, if that makes sense so far. Again, we're identifying what we're starting with, what we're ending with. That should be the easy part. Perfect. All right, so let's go ahead and take a look here. So I'm going to start off with what I know, which again is 3 moles of hydrogen for the cesium version. Again, whenever I'm on your color slide, again, you should have chosen blue, purple, yellow, or pink. I highly recommend take a picture of it. All right, so we're going to start off with the blue version. So we start off with 3 moles of hydrogen. And again, I first need to go from moles to moles of the new chemical. So you can see here I get rid of moles of hydrogen by putting it on the bottom. And I'm solving for moles of the new chemical on top. Now this mole ratio always comes from the chemical equation. So whatever your coefficient of cesium hydroxide is here on your balanced equation goes on top here. Smiley faces emojis in the chat box if that makes sense. You should have balanced your equation correctly. Whatever that coefficient is goes on top. Whatever that coefficient is goes on top. Beautiful. Then whatever the coefficient is for hydrogen goes on the bottom. Easy peasy. That absolutely always has to come from the chemical equation. Then, here we go. The final conversion is we want to go from moles of our new chemical to grams of our new chemical, which in this case is cesium hydroxide. And to get from moles to grams, we need molar mass. And it literally says it right here for you. Again, it's very obvious. A lot of it is set up for you. You just need to be able to do the basics. All right, that's the expectation. We've done 7 days of this. We should know stoichiometry at this point. All right, so here's our molar mass of cesium hydroxide. Whatever's next to grams goes on top. Yes, just plug it in, plug it in. And whatever's next to moles goes on bottom. We actually know what's next to moles here. Tell me in the chat, what is next to moles here? It's a blank number. It's no number. No number or blank number means what? What is next to moles? Blanks or no numbers mean what? Thank you, Annabelle. Thank you, Camilla. Thank you, Gabriel, Daniel, Malin, Miles. Yeah, it means 1. So 1 mole would be on the bottom. All right? All right, so then you just multiply what's on the top. So 3 times whatever those other numbers are. You multiply what's on the bottom. 1 times blank times 1. Once you have your top, once you have your bottom, just divide the top by the bottom, and that will give you your final answer. Again, this is just a fraction. Again, it's just top divided by the bottom. Top goes first into the calculator, just like we talked about yesterday. All right, and then grams of cesium hydroxide, that's what I was left with. And so that's my final units right here. All right, so again, take a picture of this. If you're doing the blue version, I'm going to move on to the purple version in 5 seconds. All right, I'm going to move on to the purple version. Okay, so again, same thing here. What we're starting with is 6 moles of iodine. So 6 goes here. It's placed over 1 because anything over 1 turns it into a fraction. Then the mole ratio, I'm getting rid of moles of iodine on the bottom, solving for moles of nitrogen on the top. That always comes from the balanced equation. So the coefficient of nitrogen goes on top. The coefficient of iodine goes on the bottom. Molar mass, then we're converting from moles to grams of nitrogen. So whatever's next to grams in our molar mass of nitrogen goes on the top. Whatever's next to moles goes on the bottom, which we just said, next to moles is a blank number, which should be 1. So you get 6 times some numbers on top, 1 times blank times 1 on the bottom, and then due to the top divided by the bottom, I'm left over with grams of nitrogen, which you can see right here. Again, I'll give you 5 seconds to take a picture of this one if this is the one that you will be doing. All right, again, all of these are set up very similarly. The instructions are therefore pretty much the same for all of them. So I know it seems redundant. That's because it is redundant. All right, let's take a look at yellow here. All right, so grams of oxygen from 4 moles of water. So we know we have 4 moles of water. You need to wait. It's put over 1. We get rid of moles of water on the bottom, solve for moles of oxygen on the top. That again comes from our equation. So moles of O2 goes on top from our equation. Moles of H2O goes on the bottom from our equation. And molar mass conversion, grams per mole of oxygen, is from our molar mass. So whatever's next to grams goes on top. Whatever's next to moles, which in this case is a 1, goes on the bottom. So we have 4 times a bunch of numbers on top, 1 times blank times 1 on the bottom. Solve that, do the top divided by the bottom. I'm left over with grams of oxygen, and that goes on the bottom. All right, 5 seconds to take a picture of this one if you're doing the yellow option, and then we're moving on to pink. All right, here is the last one of the 2-step stoich problems. So here we go. We're starting off with 5 moles of potassium chloride. I want to get rid of moles of potassium chloride so you can see it on the bottom in the next step. Change it to moles of oxygen on the top, right? Moles to moles. So again, this comes from a balanced equation. So the coefficient of oxygen goes on the top here. The coefficient of potassium chloride goes on the bottom here. And then finally, to get to grams of oxygen, we need the molar mass. So whatever's next to grams of our molar mass of oxygen goes on top. Whatever's next to moles, which is a blank or a 1, goes on the bottom. So I have 5 times some numbers on top, 1 times blank times 1 on the bottom. Do the top divided by the bottom for your final answer. And again, your units here should be grams of oxygen. All right, 5 seconds to take a picture of this one, and then I'm moving on. All right, here we go. So knowing that the recording will be uploaded around 1 to 2 p.m. to help you with these, do you feel like you would be able to do this? All right, you have stars 1 through 5. 1 is like not even in my wildest dreams. 5 is as long as I have a video, I can do it. Or 5 is I can do it by myself. 3 is as long as I have a video, I can do it. All right, go ahead and give me those stars. How are we feeling about this? Awesome. I see Gabriel in the chat. Waiting on Michael, Christopher, Kamari, Eric, Aria, Ame, Alexis, Omar, DJ. If you are a 2 or a 1, please make sure you're talking to us in the Q&A area or the private chat with Mrs. Sepulveda. She's in the private chat with a lot of you. So Kamari, make sure you check in with Mrs. Sepulveda if you need help on something. Aria, I need a star from you, not a raised hand. Michael, Christopher. Please use the polling tools. Tell me where are you at. Assuming you have the video, the instructions this afternoon, do you feel like you can do this? Yes or no? 1, 2, 3, 4, 5. 5 is the highest. Awesome. Thank you. Just waiting on DJ. Okay, thank you. That's exactly what I need to know, Mrs. Sepulveda. All right, looking good. Okay, perfect. Awesome. Alexis, if you have a specific question, please make sure you ask us in the Q&A area or you're talking to Mrs. Sepulveda in a private chat. But again, all those instructions will be provided for you. If you are still confused, make sure that you are emailing us and we can help you through it step by step as well through tutoring. Okay, cool. So that's the 2-step problem. Let's go ahead and talk about the 3-step problem. This is the last problem of the project. Again, you only have 5 problems. You have to balance the reaction, you have to get the molar masses, the 1-step problem, the 2-step, and the 5-step problem. That is the entire project. Okay, so this time we're going to be taking a look at Avogadro's number. We know 1 mole of any substance equals 6.02 times 10 to the 23rd molecules of that substance. You do need to know how to use your calculator. Again, this E right here can be found on your calculator by using capital EXP, lowercase exp, double capital E, capital E, single capital E. The only thing that you should not use is do not use lowercase e. Again, lowercase e is something different. That's an actual mathematical thing. It's like a math number. It stands for a certain number. Okay. So again, we can put these over each other. So 1 mole over 6.02 times 10 to the 23rd molecules, or vice versa, 6.02 times 10 to the 23rd molecules over 1 mole. So this is a reference slide. Again, you don't have to do anything on this slide. It's just for your reference. So let's go ahead and take a look at the last problem. Oops, sorry, last problem. Where am I? Here we go. All right, so again, you need to have a correctly balanced equation. If your equation's not balanced, again, your stoichiometry answers will automatically be wrong. So make sure that you have this. This is from slide 6. And molar mass of hydrogen, this is the other chemical I asked you to calculate for the molar mass. That's from slide 7. So again, slide 6, slide 7, slide 6, slide 7, assuming you deleted the slides you didn't need. Again, your numbers are going to be different if you didn't delete the slides you didn't need. All right. So then it asks how many molecules of water are needed to produce 25 grams of hydrogen. Go ahead and point for me on the board. What is my known? What am I starting with? What do I have a number for? Do I have a number for molecules or for grams? What do I have a number for? Molecules or grams? I see 4 people on the board. There are 26 of you. I should see lots of arrows on the board or in the chat. What am I starting with? What am I starting with? Grams, grams, grams. Yes, absolutely. So this is what we're going to start with. Grams of, in this case, hydrogen. And what am I solving for? What am I solving for? What is the final thing that I am solving for? Again, the thing I don't have a number for. Awesome. Yeah, we're solving for molecules. Perfect. So that's what we're solving for here. So let me go ahead and show you this mind map then. All right, so we're going from grams of one chemical to molecules of a different chemical. So let's take a look at this. So grams of one chemical to molecules of a different chemical, which means I have to go through the center. So I have to go to moles of the first chemical, to moles of the final chemical. So mass to moles first, then using the chemical equation, moles to moles, and then finally using Avogadro's number, moles to particles. And again, it's already set up for you, so let's take a look at this. This is again true for all of these, all right? So no matter what, you're starting out with 25 grams of a chemical, in this case nitrogen triiodide, and ending with molecules of another chemical, in this case nitrogen. Here we're starting out with 25 grams of hydrogen peroxide and ending with molecules of water. And for the gummy bear explosion, we're starting out with 25 grams of potassium chlorate and ending with molecules of potassium chloride. Those are different, by the way. KClO3 is different than KCl. Okay, so let's go ahead and try this out. So again, we're starting off with what we know, which was the number 25. So I would fill in here 25 grams. Okay, and again, it's the same number for everybody. So everybody's starting off with 25 grams. Your answers will be different though because everyone has different molar masses. Okay, and 25 here. Again, take pictures as we're doing this. Okay, now taking a look here. So we need to get to moles of the original chemical. So grams to moles means we need a molar mass. So whatever's next to grams this time goes on the bottom. Smiley faces if you see that there. Grams actually goes next on the bottom here of this molar mass conversion. Smiley faces emojis in the chat if you understand. Thank you, Gabriel. Thank you, Annabelle. And on the top, whatever's next to moles goes on top. So taking a look here again, what's next to moles here? In a molar mass, that blank means what? Blank means what? There's no number next to moles, which counts as what? As 1. So if everybody will have 1 on the top here in the molar mass conversion. Everybody. So this is also true here. This is also true here. And also true here. Okay, so whatever is next to grams goes on the bottom, and 1 mole goes on the top. Grams on the bottom, grams on the bottom. Okay, so then the next step is to talk about the mole ratio. So we're getting rid of moles of hydrogen peroxide here, changing it to moles of water. And again, that always comes from the chemical equation. So you can see here moles of water goes on top, moles of hydrogen peroxide goes on the bottom. Same thing with our other problems. Moles of water goes on top, moles of hydrogen here goes on the bottom. Here's our purple version. Moles of nitrogen goes on top. Moles of nitrogen triiodide, Ni3, goes on the bottom. And same thing here. Moles of potassium chloride goes on top. Moles of potassium chlorate, KCl3, goes on the bottom. Go ahead, give me a green check, orange X if you're following along so far. Again, you'll have the recording. You'll have pictures of this. Again, I'm not just leaving you on your own. I'm just kind of going over it quickly so that you get a heads up of what this looks like. Cool beans. All right, so we finally got to moles of our new chemical. All we need to do, though, is to finally get to molecules of our new chemical. And again, we have a conversion between molecules and mole. Whose number do we have? Whose number do we have? Tell me in the chat. Molecules and moles, whose number do we have? It's literally also up on the board. I see Gabriel. Think of a guacamole. Whose number do we have to go from moles to molecules? Avogadro's number, and it literally says it right there. We need a conversion using Avogadro's number. Now specifically, it wants molecules on top and moles on the bottom. So going back to here, the only one that has molecules on top and moles on the bottom is this one. So everybody will have 6.02 times 10 to the 23rd molecules on top and 1 mole on the bottom because Avogadro's number is only ever talking about 1 mole. All right, so taking a look here, we have 6.02 E23 on the top, all over 1 mole on the bottom. Right here, we have 6.02 E to the 23rd molecules of nitrogen on the top, all over 1 mole of nitrogen. Here we have 6.02 times 10 to the 23rd molecules of water on top for every 1 mole of water. And here we have 6.02 times 10 to the 23rd molecules of potassium chloride on the top for every 1 mole of potassium chloride. Now you'll notice that these actually all look identical to each other. The only thing that will be different is everyone's grams will be different and everyone's mole ratios will be different, which is why you do not end up with the same answers. But the basics here all look very similar. Then we multiply the tops, we multiply the bottoms, and then we just do the top divided by the bottom for our final answer. And don't forget, the only unit that didn't get canceled out was molecules of potassium chloride here, and so that's what I'm left with. Please take 5 seconds to take a picture of this if you're doing the pink version. All right, here we go. Taking a look over here. Again, we're going to multiply the tops, multiply the bottoms, do the top divided by the bottom for our final answer. And again, molecules of H2O is what we're left with. That's our units down here. 5 seconds to take a picture of the yellow version. Yeah, interestingly enough, Gabriel, I actually had to be prescribed potassium because my doctor, I was having some heart palpitations, and so my doctor ran some tests, and they were like, well, you have low potassium, so you need to eat more bananas or potatoes or spinach, and we're going to prescribe you a dose of potassium so that your heart stops skipping. So that was my recent medical adventure. All right, purple version. Again, we can see it kind of set up the basics. You would multiply the tops, multiply the bottoms, do the top divided by the bottom, and this time molecules of nitrogen are left over, and so that is what is our final answer. Our French fries? No. All right, 5 seconds for the purple version. Oh my goodness. I have not had Subway since I was in grad school getting my master's of education because every Monday I would have to go there after work and then take a 4 hour class at this college. And I would rush to Subway right beforehand because it was right next door and grab a sandwich, a foot long, so that I could eat during those 4 hours. But since then, I have never been able to step into a Subway again. Like once I graduated and got that degree, I was like, I'm never going to Subway again. I know, bananas are the worst. Like I'm eating them because I have to, but they're really the worst. Come on, guys. Of the fruits, they're not my favorite. All right, so here's the blue version. Again, multiply the tops, multiply the bottoms, do the top divided by the bottom, and this time we're left with molecules of water. So that's what goes here. 5 seconds to take a picture of the blue version. Yeah, Jadelyn, for rounding, yeah, just round to 2 decimal places. That's always a good question. Always round to 2 decimal places. All right. Yeah. Awesome. Okay. So that is all of those. Go ahead and I'm going to give you your stars again, 1 through 5, if that makes sense. Again, if you feel like you can do it on your own, give me a 5. If you feel like you can do it with the video, give me a 3. If you're like, I wasn't paying attention, give me a 1. All right. Go ahead and tell me how you're feeling. I do need responses from everybody. Otherwise, you will not be able to get your attendance. So Christopher, 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 Kamari, 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 Eric, Eric, Eric. Gabriel, I see you in the chat. Waiting on Kale, Kale, Kale. Tan, 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 Alexis, Alexis, Brian, Brian, Canyon, Adriana, Adriana. Stars, stars, stars. Thank you, thank you, thank you. Stars, stars, stars. Eric, 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 Eric. Tan, 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 Tan. Bryce, 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 Bryce. Adriana, Adriana, Adriana. Adriana, Adriana, Adriana. I love tamales. All right, looking good, everybody. I'm going to go ahead and get that done. Awesome. All right, let's go ahead and wrap on up here.
Alrighty, everybody. So we had a lot of information today. Hopefully you took pictures. Hopefully you can watch the recording and go over it if you need to be, or if you're in the spot of feeling good, let us know. So I'm going to go ahead and give you this, your whiteboard tools. Go ahead and use your pointers real fast. How are you feeling about this? Hopefully you have an understanding pretty good. If you still need help, hopefully the video will help you out with that. Awesome, awesome. Yes, Gabriel, Mrs. Sepulveda does make tamales. Oh, they're so good. I should make them, but they take all day. Excellent, everybody. Let's go ahead and move on. Perfect. So we're going to go ahead and stop our recordings right here. I'm going to grab the new row recording. Mrs. Larkin's got the other recording.